Now let's see this. I have arranged all the types of memories in form of a pyramid here. So we shall compare each one with respect to what will be the access time, frequency, size and cost. Okay. Now before that, there are various types of accesses, you know. One is called as random access. Random access means if you can go to any part or any point in the memory, then that is called as random access. Coming to cache and main memory, they are random access, which means if this is the cache or main memory, you can go to any byte in this directly, right? But then if you look at semi-random access, it means that example is magnetic disk. So semi-random means you will not be able to go to every byte directly, but then you will be able to go to some parts directly, and from there you might have to go sequentially. For example, in a magnetic disk, if you say this is the block, we can go to the block directly, right, or a track directly, we can say. See, if it is a track, we can go to the track directly, and then after going to the track, I might have to wait for some time so that the required byte or the block comes under the read-write head. Therefore, it is not random access, it is semi-random access. And coming to the magnetic tape, so magnetic tapes are not really used these days. They were used very long back. Maybe you can think of the cassette as a magnetic tape, the cassette which you used to have the audio on it, right, if you had seen it. Now coming to the cassette, what happens is, if you have to go forward or backward, you have to gradually turn it, right? You have to gradually let it pass under the read-write head. Therefore it is completely sequential. So now coming to the access times and all, I am arranging everything like this, right? So first thing is, if you observe it, access time means what I mean to say is fastness, that gives the fastness in which you can access it. So if the access time is less, it means that the memory is faster. If the access time is more, it means that the memory is slower. Now if you see this, access time actually increases as you go down the lane, which means fastness is actually decreasing. Got it? So what I mean to say is, registers will have least access time compared to cache, and cache will have least access time compared to main memory, and main memory will have less access time compared to magnetic disk. Magnetic disk will have less compared to magnetic tapes, right? Therefore if you see the access time, it increases down like this, but then it doesn't mean that the one having higher access time is faster, the one having lower access time is faster. Therefore when you look in the terms of access time, obviously registers is the best, right? Okay. And now the frequency of usage. So frequency of the usage is nothing but how many times you are actually referring to it. Okay. So most of the time our CPU will try to read from the registers. If it is not present in the register required information, then only it will go to cache. If it is not present in the cache, it will go to main memory. If it is not present there, then it will go here, right, like that. Therefore if you see this, many times it will be accessing registers, and then this, and then this, and then this, like this. Therefore frequency has to decrease down the lane, or frequency will increase up, right? So least frequently used, next frequent, next frequent, next frequent, like that. And coming to the size of it, registers are actually costly, therefore we don't go for high size. So we then generally take the cheaper memory to be at the higher size, right? As you increase the size of each component, the cost is going to increase, and since it is of too much cost, we don't take too much of it. Therefore size of magnetic tapes will be highest because it is cheapest, and then this one will be next highest, next highest, next highest, right? So size is also going to decrease down the lane, okay, increase down the lane. So your size of this one is least and your size of this one is highest. Okay, so coming to size, least is at the top and highest is here. Coming to frequency, highest is here and least is here, right? And coming to access time, least is here and highest is here. And coming to the cost of magnetic tapes is cheapest, right? And this one is next. So registers is having the highest cost, and next one is cache, and next one is main memory, like this. Therefore cost is highest for registers and least for this. Got it? Okay. And now if you see the implementation, registers are implemented with flip-flops, and flip-flops we have discussed in digital. What is a flip-flop and how to build it. and cache is implemented with static RAM, and we have discussed RAM to some extent, right? But more details are not required. Whatever are required we discussed in digital. Okay, more details are not required. And coming to main memory is implemented using DRAM. Static RAM is generally faster than DRAM, that is why cache will be faster than main memory. And whatever details are required we have discussed them in digital, and whatever is not there in the syllabus, don't worry about it. Okay, so we are not interested in implementation in this part, we are just interested in connecting them. Okay, fine. Now the purpose of the memory hierarchy is to bridge the speed mismatch between fastest processor to the slow memory at a reasonable cost. So what we try to do is, we generally have some budget, and within that budget we try to have all these components in such a way that the overall memory is not too slow or it is not too costly, right? We are trying to hit the trade-off where we want to keep the cost as low as possible and we want to keep the speed as high as possible. So what is speed here? Now the bottleneck, since the bottleneck is memory, if we increase the speed of the memory, we can go close to the speed of the processor. Got it? So this is the trade-off we want to hit. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.